Hi, welcome to the OPOLab, the OSSD grade 10, PM2G, and Chapter 7, Similarity, Triangles, and Trigonometry. So this chapter we're gonna talk about the several geometries about the triangles. Okay. The first section is the similarity triangle. So what that means? So here is two triangle called triangle y is ABC, and the second one is the DEF. Okay. So what's the similarity? Like we give the two letters for S. It's in the different side. It's like for AB or BC and AC. For the angle, it means like the BAC and or like the angle EDF. So let's talk about how to know if there is triangle similarity. That's the first one. It's called the SAS. Is the type 1. We have two conditions. If angle B equal to angle E, and there is not form for AB over BC equal DE over EF. They have the same value like for the K, so we can know that we can get that there are two angles for similarity. So this symbol we call the similarity like that. Okay, that means there are two angles like for the same size are equal, and the AB compared to the over the DE and the BC over to the EF, they are the same value. Like for 3 over 5 equal to 6 over 10. So, okay. That means there are two sides and there are two sides 1, two sides 2, and there is the angle in the middle of the two sides. So we can say that the two triangles are similarities. Let's talk about the second one. Second one is the easiest one for side. There are two sides are equal to value that we do not take care about like the angle. Only talk about for the size. And for size 3, the third size are also become overreach the value, so it can make it to the similarity size. That's the opponent. Because for 3 sides we can draw the only one triangles. Okay, that's for AB over DE equal to BC over to the EF, and equal to AC equal to DF equal to K as the value. So also we can get the triangle ABC similarity to triangle DEF. Okay, let's see the third one called AA. It's only with the two angles are similarity. That means one angle ABC and DEF. And the ABC and DEF, they are the two angles for here. The second one is ACB and AFE. That means ACB equal to triangle DEF. So that means we can cancel the two angles here. And Okay, we can directly get the size here. Just you can connect them for equal A and equal D. Okay. So we have the C way to method to get the one similarity triangles. So we have the three conditions. When there is a special case, if for when k equal to 1, like for this k equal to number 1, so that means the similarity triangles like the triangle ABC similarity to DF, so that means there will be to the equal. That means the two triangles are same, because like the where A equal to B equal to 1, that means A equal to B. So we can know that AC equal to DF, like the AB equal to DE and BC equal to FE. Also like the three triangles are to compare of together, so that are the same. Okay, let's do an example here. Let's talk about the big triangle where two triangles are together. We call that the bigger one is triangle ABD, and the smaller the one DFC. And there are two lines are parallel. That means the EC parallel to the AB. So we can get the angle y equal to angle 2. That means these two angles. Okay, let's first we need to prove that it is the similarity angles for there are two triangles, because we can write. Okay, first we can write that if C parallel to the BA, we can get angle y equal to angle 2 and CD equal to BDA. Also, there is the same angle for same triangles, so we can directly get the DE similar to a BDA, so that the smaller the y similar to the big one. So we can write the other size pairs, like for CD equal to over to BD. Also we can write like the DE equal to over to DA. Also we can write like that for DE over to BA. They are the same values, so they are the two pairs. So because now we can get number here, like for CD equal to 6 and CB equal to 8. And we also know that C equal to 5, so we can write that C. So we can get allocated x, that for 6 over 14 equal to 2 over 7 x. So the x equal to 5 times 7 over 2. So equal to 35 over 2. So we can not get the axis. So that's the end of the section. Hi, welcome to your biology lab. This is the OSSD grade 10 NPM 2D chapter 7 similar triangles and trigonometry, section 7.2. So this section we're gonna talk about to summary some typical graphs for the similarity triangles. So the type 1 is you can get this type is called the is for type 1 is similar to the A, and the second one is the X type. That's the two typical. Let's talk about the first typical. We have already solved it in the last section. It's for triangle ADE similar to the triangle ABC. So with the small and the similar to the big one. Okay. So first condition is that we can get the parallel DE equal to BC. You can write and we can get so angle AED equal to angle C. Also we can write down ACB. Also the angle A are the same angle, so we can add angle AE equal to. So you can use the third condition for A. So we can get the angle ADE similarity to the ABC. Also we can get some of the conclusion here. Like for AD over to the AB equal to AE over to AC. Okay. Now let's talk about the second type called the X. The X type. So that means also we can get the MN parallel to the PQ, so we can get angle M equal to angle Q. Also the two angles are same. So we can use the two for two angle at the west side. And we also use the two angles because triangle like the OM because there is in this triangle equal to angle like the OQP, and like for M also MON equal to angle QOP. So we can get the similar to the QPN. So that means this graph we can cut down and we can move this triangle down, so they're the same. So also we can get so this two sides has R over equal to some value. So first one is MO at QP. The second one is the OM and PM. The third one is MN and over to QN. Okay. Okay. Let's see the second type is called the right angle. That means there are two right triangles. That means there are y angle are equal to 90 degrees. So we can where AB equal to 5, when equal to 5.2, and this D equal to 2.6, and the Y equal to 3.4, and we can also get that the two angles are same, like the angle C equal to angle F. So we can use the two angles, because since B equal to E equal to 90 degrees and C equal to F, so we can directly get two right angles. So we can put that RT right. So we can get two sides over pairs, there's three pairs together. And we can write the value here for AB equal to 5.2 for here and 2.6 for the DE. Hi, welcome to the OPOLab lab. This section is the OSSD grade 10 npm2d. Chapter 7, Similar Triangles and Trigonometry. Section 7.3, Exploring Similar Right Triangle. So yeah, this section we're gonna do an exploring the right triangles. Okay, now we just okay, first there is the triangle for called ABC, where B equal to 90 degrees, and there is the definite line called E and D, G and F. So we can get they are parallel, so that the D equal to 90 degrees and the F equal to 90 degrees. Okay, so first we can prove that there is a similarity for because A equal to EAD and angle EDA equal to triangle CBA. So we can get that triangle ADE similarity to the ABC. Okay. And that with the same way we can get similar to, also we can get the two AFG. So we can get like that the two pairs, like the AD over AB equal DE equal to PC. Okay, so we can write that for if we switch the position, we can write that AD over AE and DE over AE. And ADK over DE. So for the angle A, so that means for the triangle ADE, you can get that if the side of DE over AD that is same value, or AD over AE. So whatever like the triangle is the AGF, we can get the same way code. Get like the AF equal to a GF over AG. So we can get that whatever the right triangles for the one size A, we can get the different type of like the pair. That's the same way. So yes, we can go that the triangle ratio. We're gonna continue to talk about the next section. So that hi, welcome to the OPOLab, the OSSD Grade 10 NPM 2D, Chapter 7, Similar Triangles and Trigonometry, Section 7.4, the primary trigonometric ratios. So yeah, this section we're gonna talk about the details for the more detail for the right triangles. So let's see the first one. Okay. First, there is a triangle called ABC. There is the big triangle, and there is for the middle point at M at N. Okay, is the typical quadrature for the A. We already talk about the previous section. Okay, and this the angle B equal to 90 degrees. So we can know that AM equal to 4, AB equal to 4, the N equal to 5, the Cn equal to 5, and the longest side for BC equal to 6, and there is A. Okay, so we can get how to prove it. If triangle MM and B equal to CAB, that means this angle. And so cos there is the parabola, so that this angle equal to 90 degrees. So we can directly get this one called triangle NM similar to the angle CAB. So also we can write down the three pairs. Okay, we can get the 4 over 8 equal to 3 over 6 and 5 over 10. So yes, over to the y over to equal to k. So I mean whatever I like, if I put the middle line for this one, it also says similarity for the all of triangle. So now we can get the similar is ratio for the y over 2. That means whatever the angle was degrees, and the other angle is 90 degrees, so the ratio is all the same, whatever the size. So now we can learn like the ratios for the angle, because the ratios of RT triangle. Oh, now let's talk about the three primary ratios. Let's talk about for angle A for the basic angle. Okay, so let's just directly talk about these angles. Okay, so the first one is called the sine A. What sine A means? Sine A means the BC equals to AC. That means for this side equal to the 5. So you got the C over 5. It is for the angle A. The second one is the cosine eta, means BA equal to over AC. That means for BA, that means that it is set for the 4. Okay. So 4 over the same side for the 5. 4 over 5, so that means the second ratios for the one side over the hydrated side. That means the for this side. Not vertical sides. The third one is called the tangent A. Tangent A equals the two vertical sides compared the horizontal sides with the 3 overall. Also, we can directly get like the 4 for the y is also the denominator is for the 3 and the second one is 4. So we can also write that the sine over cosine A. That means BC over AC. So that means 3 over 5 times the 5 over 4. We can cancel out the 5, so we can get the for 3 over 4. That's the primary basic C triangle ratio. That's the end. Welcome to the OPOLab lab. This is the OSSD grade 10 NPM 2D. Chapter 7. Similar triangles at the trigonometry. Section 7.5. Solving right triangles. So this section we're gonna talk about like some typical graphs for the angle ratio. So the first one is called the triangle ABC and angle B equal to 90 degrees. And we can check out that the AB equal to 7 and AC equal to 25 and BC equal to 24. So now we need to write out the three law of that for sine A and cosine A and tangent A. Okay, so sine A we can write that for, we can get that for is the BC, that means this is angle A. So the y is for the BC is the opposite of A. That means, and for the letter do not vertical and horizontal are called AC. So it's called the (24 over 25). For cosine A, is the another way for AB is the same AC, because the denominator AC are same. So it's for the 7 over 25. So for the tangent A equal to sine A over cosine A. Is the 24 over 25. Okay. That's the third one. Okay, the sixth one is called the 30 degree. So let's do the same process. Okay. For sine A, the second one is called the cosine A. The third one is tangent A. And for the sine A equal to BC equal to A over AC, so it's equal to 1 over 2. So for the cosine A equal to root 2 over 2. For the theta is 1 over root 2. So we can get the root 2 over 2. So now we can get it as y summary for the 30 degrees. And for sine 30 degree equal to 1 over 2. For cosine degree equal to root 2 over 2. And for tangent equal to 2 over 2. Hold on. No, wait, this side is for the 3. Okay. Okay, 3. Okay. Let's correct that way. So yeah, 30 degree equal to 1 over 2, and the cosine 30 degree equal to root 3 over 2, and the tan theta is 1 over root 3. Okay. That's the important special angle you must remember. Let's see the second one is the 45 degrees. Next, and the AB equal to AC equal to 1 and the AC equal to root 2. Okay. Okay. So let's write the set. For sin theta 45 equal to AB equal to AC. So that means 1 of so it's called the AB equal to AC, so that the cosine 45 degree equal to sin 45 degree. That means the same 1 over 2 root 2. The second one is theta 45 equal the AB equal over AC, because there are only 1, so that the answer is 1. Okay, it's for the second special angles you must. Welcome to OPOLab. This is the class OSSD grade 10 AM2D. Chapter 7 Similar Triangles and Trigonometry. Section 7.6 Solving Right Triangles Problems. Okay, let's see the first examples. For there is a triangle called ABC and AB equal to 8 and angle equal to 35 degrees. We must to solve for the x. So how to do this type of question? So we can directly write the for first one called the tan 35 degree equal to x over 8. So if the naturally get the x equal to 8 times tangent 35 degree. So we can use the calculator to know that tangent 35 degree equal to 0.7. This is nearly to the 5.6. Okay, that's the sixth one. Triangle here, there is a height here called h. First, we can use at 40 degrees. That means sin 40 equal to h over 50. So we can use the h equal to 50 times sin 40 degrees to present this height. Now we can use the area from the area equal to 1 over 2 times the b times the h. times the 20 degree and degree. So the question is find area. Okay, so the area is equal to this one. The third one is we have the two triangles. The first one is 37 and the second one is called 21. For the main, we need to find the totally edge. First one, we use the triangle so we need to use the theta 77. Use the first triangle. Okay, now set A equal to the second one we use the theta 21 degree. We can preset to the B over 200. So yes, can you now get the B equal to 200 times the theta 21. So now for the height is equal to this formula plotted together. That's the end of this